Hi everybody. So in this video we're going to look at modelling motion where the acceleration is a variable. So this will involve some calculus. So we know that displacement, and if we know displacement we can work out the velocity, and this is ds by dt. And from the velocity we can work out the acceleration, which is the rate of change of velocity over time, or d2s over dt squared. And throughout this video, we'll be applying these relationships. Okay, so in example 1, we're told that a particle moves in a straight line and at time t has velocity v, where v is its function, and time is increasing from 0. For part A, we've been asked to find an expression of the acceleration for the particle at time t. So we're going to use this relationship here, where A is dv over dt. So we can work out dv by dt by differentiating this velocity function. If we differentiate 3t, we get 3. When we differentiate 18e to the negative t, we'll use the chain rule. So we'll multiply this 18 by the derivative of this negative t. So this will be positive 18e to the negative t. So our acceleration then is 3 plus 18 over e to the t meters per second squared. So I find it easier to write this as a fraction. Okay, so for part B, state the range of values for the acceleration of a particle. Well, we know it starts when t equals 0. So when t equals 0, we'll substitute 0 into our acceleration function. So a will equal 3 plus 18 over e to the 0. Well, e to the 0 is 1, so this becomes 18 over 1. So our acceleration then is 21 meters per second squared. And then as t increases from 0 and it becomes very large, let's say t approaches infinity, then a will now be 3 plus 18 over e to the infinity. And this becomes a very large value. So when you divide 18 by a very large number, this will tend to 0. So our acceleration then will tend to 3 meters per second. So given this as a range, we'll say A is less than or equal to 21, but greater than or equal to 3 meters per second squared. Okay? And then for part C, given that when t equals 0, the particle is at the origin, find an expression for the displacement in terms of t. So if we know that velocity is a derivative of displacement, then displacement will be the integral of velocity with respect to time. So all we need to do now is integrate this function with respect to t. So the displacement then, if we integrate 3t, this becomes 3t squared over 2. So 3 over 2t squared. When we integrate the 18e to the negative t, we'll apply the reverse chain rule. And this will give us positive 18e to the negative t. But we also need to add the constant of integration. And we're told in the question that when t equals 0, the particle is at the origin. So this means that when t equals 0, s will equal 0. And we'll substitute these boundary conditions into our equation. So 0 will be 3 over 2, lots of 0 squared, plus 18e to the negative 0 plus c. Well, we know this will go. This will become 18 times 1. So 0 will be 18 plus c. And therefore, c must equal negative 18. So the displacement then will be 3 over 2 t squared plus 18e to the negative t minus 18. Okay? Let's move on to example 2. Okay, so in example 2, we're told that a particle moves in a straight line and that time t has velocity v given as its function. And then for part A, we've been asked to find an expression for the acceleration of a particle at time t. So we need to work out dv by dt. So if we differentiate this, we get 6t. So A will equal 6t. We can differentiate this using the chain rule. We'll differentiate sine and we get cos. Then we'll multiply this by the derivative of the inner function. So we get 3 cos 3t, which we'll multiply by the 2. So this will give us minus 6 cos 3t. And this constant of 6 will just go. So this is our expression for the acceleration in terms of t. For part B, when t equals pi over 3, showing that the acceleration is 2 pi plus 6. So all we need to do is substitute pi over 3 into our t value here. So A will be 6 lots of pi over 3 minus 6 cos. And when you substitute pi over 3 into here, the division and the multiplication of 3 will cancel. So this will just become 6 cos pi. We can simplify this fraction. The 6 and the 3 will cancel to make 2. So A will be equal to 2 pi. And then because of pi is negative 1, times this by negative 6. And we get plus 6. And for part C, when t equals 0, the particle is at the origin, find an expression for the displacement of the particle from the origin at time t. So we know displacement is the integral of velocity with respect to time. So S will be the integral of 3t squared minus 2 sine 3t plus the constant 6. When we integrate 3t squared, we get 3t cubed over 3, which will simplify to make t cubed. When we integrate sine 3t, we get negative 1/3 cos 3t. This negative and this negative will cancel. So we've got positive 2 over 3 cos 3t. When we integrate the 6, we get 6t plus the constant. And we told him a question that when t equals 0, the particle is at the origin. So when t equals 0, s equals 0. And these are our boundary conditions to work out c. So 0 will be 0 cubed plus 2/3 of cos of 3t, which is 0, plus 6 lots of 0, plus the constant. And we know that cos of 0 is 1, so 0 will equal 2/3 plus c. So c must equal negative 2/3. Then we can substitute this back into our equation. So the displacement will be t cubed plus 2/3 cos 3t plus 6t minus 2/3. Okay, let's try one more example. Okay, so for example 3, a particle P moves on the x-axis. At time t seconds, the displacement of P is s meters in the direction of x increasing, where s is given by this piecewise function. Find the velocity of P when t equals 5. Okay, so because t equals 5, we're going to use this upper function. So if we just say that s is equal to t minus 3 when t equals 5, and we want to work out the velocity, which means we need ds by dt. So if you work out ds by dt for this function, the constant negative 3 will go, and we'll differentiate with t to make 1. So this will be 1 meters per second. Okay. For part B, when t equals 22, the 22 means now we're going to use this function, because it is greater than 8. So s will be the square root of 4t minus 7 when t equals 22. And to work out the velocity, we need to find ds by dt. So I'm going to rewrite this using powers. So s will be 4t minus 7 to the power of a half. And we can differentiate this using the chain rule. So v will be, we'll bring this power down, and we get 1/2. Lots of the inner function. We'll take away 1 from that power, and then we need to multiply this by the derivative of this inner function. So we need to multiply it by 4. And we can simplify this. 1/2 times the 4 will give us 2. So we'll have 2 over the square root of 4t minus 7 meters per second. And when t equals 22, v will be 2 over, well, 4 times 22 will be 88, and 88 minus 7 will be 81. So over the square root of 81. We can simplify the square root of 81 to make 9. So our velocity will be 2/9 meters per second. Okay. Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again and take care.